Welcome back, students. So today let us discuss about some of our textual exercises based on potential energy and law of conservation of energy. For the questions, you may please refer your NCERT science textbook, page number 158 and 159. Okay. So now let us move on to page number 158, question number 3. In your textual exercises, question number 3, and question is, a battery lights a bulb. Describe the energy changes involved in this process. So, a battery is used to light a bulb. We know that inside the battery we have chemicals stored in it. So, there is, when chemicals reacts or when chemicals burn to give energy, there is a chemical energy involved. So, the chemical energy of the battery is converted into electrical energy, and finally when electrical energy reaches the bulb, it gets converted into light and heat energy. So, energy conversion is chemical energy into chemical energy to electrical energy back to gets converted into light and heat energy. This is the energy conversion that takes place in lighting a bulb using a battery. That is, chemical energy gets converted into electrical energy, again which gets converted into light and heat energy. Now moving on to question number 6. The potential energy of a freely falling object decreases progressively. Does this violate the law of conservation of energy? Why? So, according to law of conservation of energy, the total energy should remain constant, and we know that as an object falls down to the ground, its height gets reduced. The height gets reduced. As a result, we know that potential energy is mgh. So, as height gets reduced, potential energy also gets reduced. But according to conservation of energy, the total energy should remain a constant. So, is this a violation of the law of conservation of energy? That is a question. Answer is no, because as the object falls down, the height gets reduced, which decreases its potential energy. But as an object moves down, its velocity will increase. Thereby, when velocity increases, we know that kinetic energy is equal to half mv square. So, when velocity increases, kinetic energy also increases. So, when potential energy decreases, kinetic energy increases with an equal amount, making the total energy a constant. So, when potential energy increases, the kinetic energy when potential energy decreases, the kinetic energy will increase with the same amount as of the decrease of potential energy. So, the total energy remains the same. So, that is, if potential energy decreases by 2 units, kinetic energy will increase by 2 units. So, this balances the total energy and makes the total energy a constant. So, it does not violate law of conservation of energy. The increasing kinetic energy and the decreasing potential energy will satisfy law of conservation of energy. That is the answer for 6th question. Now, moving on to 7th question of your textual exercise. What are the various energy transformation that occur when you are riding a bicycle? Seventh question. When you are riding a bicycle, what is the energy transformation that occur? So, when you are riding a bicycle, in order to ride a bicycle, you have to pedal it. So, you need the muscular energy. You need you use your muscles to ride your bicycles. So, you use your muscular energy, and that muscular energy, you use the muscular energy and you pedal it, and as a result the cycle will start moving. So, the cycle started moving. So, the energy possessed by a moving object is kinetic energy. So, this muscular energy got converted into kinetic energy. At the same time, you people will sweat, or you will feel warm. So, muscular energy got converted into kinetic energy and heat energy, which makes your body warm. Okay. So, this is the energy conversion that occur when you ride a bicycle. Now, next question is question number 8. Question number 8 of your textual exercise. Does the transfer of energy take place when you push a huge rock with all your might and fail to move it? Where is the energy you spend going? So, that you are spending energy in order to move a huge rock. But even though you spend energy, the rock didn't move. You have done work, but the rock didn't move. So, where did that energy that you spent gone? So, over there you spent your muscular energy to move the rock. You use your muscles to move the rock. So, you spent your muscular energy to move the rock, but the rock didn't move. But you people will sweat. So, all the muscular energy which you spent to move the rock is converted into heat energy in the form of sweat, the form of body sweat. Okay, that is the answer for 8th question. There too, even though the rock didn't move, the muscular energy that you spent is not lost. It was just converted into heat energy. Satisfies law of conservation of energy again. Okay. Now, moving on to 10th question of textual exercise. 10th question, that is, an object of mass 40 kilogram is raised to a height 5 meter above the ground. What is its potential energy? If the object is allowed to fall, find its kinetic energy when it is halfway down. Okay. 10th question, page number 156. Question number 10. Sorry, page number 158. Page number 158, textual exercises, question number 10. Question is, an object of mass 40 kilogram. So, mass of the object is 40 kilogram and it is raised to a height of 5 meter. So, height of the object is 5 meter above the ground. What is its potential energy? You need to find its potential energy. Formula to find potential energy is mgh. mgh. Now, substitute all the values in the equation of potential energy. You will get EP is equal to 40 into G. G is 9.8 into H is 5. On solving this, you will get the answer as 1960 joules. After multiplication, you will get the answer as potential energy is equal to 1960 joules. Now, second part of the question is, if the object is allowed to fall down, So initially it was taken up, and at the maximum height it had a potential energy of 1960 joules. Initially an object was raised to a height h, and when it was at a maximum height, the maximum potential energy it has is 1960 joules. Now the object is allowed to fall down. So the object is falling down. When object falls down, height decreases. So potential energy also decreases. As the object descends, velocity increases. Therefore kinetic energy will increase. This is what happens when an object falls down. When an object falls down, height decreases, which decreases the potential energy, and as the object descends down, its velocity will increase, which in turn increases its kinetic energy. Now find its kinetic energy when it is halfway down. That is, suppose if this is the height h, when the object is halfway, what is its kinetic energy? We know that at halfway, at half the distance, as the object starts descending, its potential energy decreases and kinetic energy increases in equal amount. And at halfway distance, kinetic energy will be equal to potential energy. So at maximum height, potential energy was 1960 joules. When it covers half the distance, the potential energy will decrease and finally reaches to half the value. And when again it reaches the ground, potential energy becomes 0 and kinetic energy becomes the maximum. So when the object is at a height, maximum potential energy, as it descends, potential energy decreases, and at halfway, potential energy decreases to half its initial value, and finally when it reaches the ground, potential energy decreases to 0. And as the body descends, as potential energy decreases, kinetic energy will increase. And at halfway, at a half distance, when potential energy decreases to half the value, kinetic energy will increase by half the value. That is, kinetic energy will be 1960 divided by 2, which is equal to 980 joules. Because as potential energy decreases by 2, kinetic energy should increase by 2. When potential energy decreases half the times, kinetic energy should increase half the times. Then only the total energy will remain constant. So when potential energy reduces by half, kinetic energy increases by half. So initially kinetic energy was 0. At midpoint, potential energy got half. That is, the half of the potential energy got converted into kinetic energy. So when the object moves down and reaches half the distance, half of the potential energy got converted into kinetic energy, which is equal to 980 joules. Okay, that is question number 10. So initially potential energy was 1960 joules. As it descends down, potential energy decreases and kinetic energy increases. When it reaches half the way, potential energy decreases by half. To make the total energy constant, kinetic energy should increase by half. Allengil we can say that the half potential energy got converted into kinetic energy. So kinetic energy is potential energy by 2, that is equal to 980 joules. That is question number 10. Now moving on to question number 15. Moving on to question number 15. Illustrate the law of conservation of energy by discussing the energy changes which occur when we draw a pendulum bob to one side and allow it to oscillate. Why does the bob eventually comes to rest? What happens to its energy eventually? Is it a violation of law of conservation of energy? That is, you need to explain law of conservation of energy using simple pendulum. That is question number 15. That is page number 159. Page 159. Question number 15. Now consider a simple pendulum. A simple pendulum is nothing, a string and a bob attached together. This system is known as a simple pendulum, which you have already learnt in your 7th standard. When simple pendulum is at rest, this resting position of simple pendulum is known as mean position. Mean position. When it oscillates, what happens is, we move the simple pendulum to one of its sides. We move the simple pendulum to one of its sides, which is known as the extreme position. The maximum displacement of simple pendulum to one of its side is known as the extreme position. And again the simple pendulum comes back to mean position. From mean position, it again moves to the second extreme position. This is the next extreme position. And at mean position, the simple pendulum has maximum velocity. And at extreme positions, simple pendulum have minimum velocity. And at extreme position, simple pendulum possess minimum velocity, and at mean position, it has maximum velocity. And at extreme position, it have a displacement. It is covering a distance. So here, at extreme position, it is covering a distance. So it is having a displacement, which means the simple pendulum is under strain. That means at extreme position, potential energy is maximum. At both extreme position, potential energy is maximum. And at mean position, since the velocity is maximum, the mean position has a maximum kinetic energy. This is the case of a simple pendulum. Okay. Just similar to a free fall case. At a height, kinetic energy is 0 and potential energy is maximum. When it reaches the ground, kinetic energy is maximum and potential energy is 0. The midway, kinetic energy will increase and potential energy will decrease by the same amount. Similarly, at extreme position, potential energy is maximum and kinetic energy is 0. And at mean position, kinetic energy is maximum and potential energy is 0. Any point in the midway, potential energy decreases and kinetic energy will increase. This is the case of simple pendulum, just similar to the free fall condition. Okay. Now, when pendulum move from mean position to extreme position, what happens is the maximum kinetic energy gets converted into potential energy. And when pendulum moves from extreme position to mean position, the potential energy gets converted into kinetic energy. And the potential energy becomes 0, and at mean position it will only possess kinetic energy. So in the midway from extreme to mean, that is, initially the pendulum was at mean position, it only had kinetic energy, potential energy was 0. As the pendulum starts oscillating, the kinetic energy gradually decreases and potential energy gradually increases. And as it reaches the extreme position, the potential energy reaches its maximum value and kinetic energy gets reduced to 0. And as it oscillates back to mean position, the potential energy decreases gradually and kinetic energy increases by the same amount, and by the time it reaches the mean position, it acquires maximum kinetic energy and 0 potential energy. That is, during the oscillation, kinetic energy and potential energy gets converted from one form to another. From moving from mean to extreme position, kinetic energy gets converted into potential energy. Moving from extreme position to mean position, potential energy gets converted into kinetic energy. One form gets converted into another. Energy is neither created nor destroyed. One form of energy got converted into another. Now this continues, this oscillation continues. After some times, the bob comes to rest due to the air resistance. The resistance given by the air, the bob comes to rest. So what happens is, the pendulum is in continuous motion and the pendulum is suspended in air. So the air is continuously giving resistance. So the pendulum spends some kinetic energy to overcome this resistance. The pendulum spends its kinetic energy to overcome this air resistance, and that is, it is spending its kinetic energy, and finally the pendulum gets heated up and comes to stop. So the kinetic energy of the pendulum got converted into heat energy. Again, no energy is destroyed nor created. Kinetic energy got converted into heat energy. The kinetic energy which we spent to overcome the air resistance got converted into heat energy. There also, that is why finally the kinetic energy loses and comes to 0 value. That is, all the kinetic energy got converted into heat energy. Finally, the pendulum gets stopped, or the pendulum comes to rest due to the loss of kinetic energy. The pendulum comes to stop. All the kinetic energy spent was converted into heat energy. So neither the energy was destroyed nor created. One form of energy got converted into another. Okay, that is simple pendulum holds law of conservation of energy. That is question number 15 of page number 159. Now moving on to question number 21. A freely falling object eventually stops on reaching the ground. What happens to its kinetic energy? As we have already told now in the case of simple pendulum is suspended in air. So it needs to overcome the air resistance. In order to overcome the air resistance, it will spend its kinetic energy. It will use its kinetic energy to overcome this air resistance. And finally, all the kinetic energy gets converted into heat energy. In similar case happens in a freely falling object too. When a freely falling object falls, it possesses kinetic energy. And when it hits the ground, what happens is, its kinetic energy gets converted into, when it hits the ground, we can hear a sound. We will be able to hear a sound of hitting. So all the kinetic energy got converted into heat and sound energy. So the kinetic energy is not lost, it only got converted from one form to another. That is, the kinetic energy got converted into heat and sound energy. That is, energy is neither created nor destroyed. One form is converted into another. Again, holds law of conservation of energy. Hope the law is clear now. Please do make sure that the statement and the energy conservations are clear for you people. So read your textbook thoroughly. and make sure the law is crystal clear for you. Thank you.